Okay, so hello everyone. In this video, we have to discuss colligative properties. Okay, so let's start. So colligative properties. Okay, so we know what is colligative properties. Colligative properties means the physical properties of solution depends upon the relative number of the solute particles in the solution, but not depends upon the nature of that particles of solute in that solution. Right? So this is called colligative properties. Okay, so let's start. And this is also called what? Democratic properties, because this only depends on the solute particles. Okay, so colligative properties kya? The physical properties of solution depends upon the relative number of solute particles, but not depends on nature of solute particles in the solution. Particles in that solution is called what? Colligative properties. Okay, so basically we have to discuss in non-volatile liquids, because non-volatile liquids means what? The substance who do not vaporize when exposed to air. That means they do not vaporize means vapor pressure also not there. Okay, so that this is called not volatile. Okay, volatile and non-volatile. Okay, so let's start. So non-volatile substance depends upon some physical properties. Okay, so recently we have right the physical properties. So what are the physical properties depends on a particular a non-volatile substance, right? So the properties basically what? Four types are there. Okay, first one, relative lowering in vapor pressure, and elevation in boiling point, depression in freezing point, and osmotic pressure. And these are the types of colligative properties. Okay, so what are the types of colligative properties? First one, relative lowering in vapor pressure. Relative lowering in vapor pressure, or simply that is called RLVP. Okay, second one, elevation in boiling point. Okay, third one, depression in freezing point. Depression in freezing point. Depression in freezing point. Fourth, osmotic pressure. Osmotic pressure, or this is also called what? Reverse osmosis. Okay, those are used in aquaguard, right? So this we will cover in colligative properties. These are the four types of colligative properties. Okay, so let's start one by one. First one is relative lowering in vapor pressure. So what is this? So relative lowering in vapor pressure means, suppose we have to take a non-volatile, let non-volatile solute, okay, B, and volatile solvent A, right? For that, according to, we know that in last class we have discussed Dalton's dilution law, partial pressure, and Raoult's law also. So according to that, what happened? The pressure of the solution is what? Directly proportional to mole fraction of these components. Okay, that means chi A plus chi B, right? So as this is non-volatile, so what happened? The pressure PB naught, okay, this is the vapor pressure of this component for 0. Why 0? Because non-volatile means they do not have the vaporize when exposed to air. So do not have vaporize means we can study the vapor pressure also. So that why PV naught is equal to 0, right? Okay, now PS is equal to what? PA naught chi A plus PB naught chi B. So as it is 0, so what will happen? This is also 0. So what left? Only PA naught chi A. So what will happen? Chi means this is the mole fraction. Suppose mole fraction of A is n and for B is small n, right? So what? N upon n plus n, okay, and PA naught, okay, clear? So for a solution of non-volatile solute at constant temperature, the vapor pressure of solution containing non-volatile solute is directly proportional to mole fraction of that solvent, right? So now what happened? If that is directly proportional, suppose this is equation 1. Now PS is directly proportional to what? Chi, okay, chi A, okay, implies PS is equal to what? PA naught chi A, right? So this is the chi, only volatile solvent, right? Okay, so now as I have recently told that for a solution of non-volatile solute at constant temperature, the vapor pressure of solution containing non-volatile solute is directly proportional to mole fraction of that solvent. So this solvent, so this is the only mole fraction. Okay, so what happened? Now what happened? PS directly proportional to what? Chi A. So chi means what? What we get? That is the n upon n plus n, right? Okay. So as okay, so now as we can write down, so mole fraction of both components what? Equal to 1, okay, implies chi is equal to what? 1 minus chi B, right? So now as PS is equal to what? PS is equal to what? PA naught chi A plus PB naught chi B is equal to what happened? So PB naught is 0. Initially we know that it should be 0. So only PA naught chi A. So what is chi A? 1 minus chi B is equal to PA naught 1 minus chi B. Okay. So what is get? Implies PS is equal to PA naught minus chi B into PA naught. Okay, again what happen, minus PA naught is equal to minus chi B PA naught implies, so if you change this sign, okay, so what happen, if you do positive then it will be exchange this sign also. So chi B PA naught is equal to what, PA naught minus PS, right, implies chi B is equal to what, PA naught minus PS upon PA naught, right, which is equal to what, which is equal to what, so chi B is what, mole fraction of non-volatile solute. So what happen, implies n upon n plus n is equal to PA naught minus PS divided by PA naught, right. So this is the equation 2, right. Okay, so when a non-volatile solute is added to volatile liquid, then the vapor pressure of liquid decreases because less number of particles of solvent is present in the solution at its surface, okay, as compared to the pure solvent. Okay, so then what will happen, so less vapor is formed and vapor pressure of the solution is decreases. Okay, so what happen, PA naught minus PS is equal to what, delta P. Okay, and this is called what, lowering of vapor pressure. Again PA naught minus PS divided by PA naught is what, this is the relative lowering in vapor pressure. This is called relative lowering in vapor pressure. This is the lowering of vapor pressure, right. Take, so which is equal to what, this is also equal to number of moles of the solute, non-volatile solute upon number of moles of solid plus solvent, right. So let's do the derivation. Okay, so this is also equal to what, n by n plus n, right. Now we have to change, okay, denominator को will change to numerator, numerator will change to denominator. Okay, so what happen, PA naught upon PA naught minus PS is equal, it also changed, n plus n upon n. Now this form we can written as what, 1 plus n upon n. Okay, same thing if you do cross multiplication, n plus n into 1 n plus n divided by n. Okay, right. So what happened now, PA naught divide PA naught minus PS, so this one will come to this side, so what happened, minus 1 is equal to n divided by n. Now what will happen, this form, now PA naught, this will be multiplied with 1, so what, 1 into PA naught minus minus plus plus PS whole divided by what? PA naught minus PS is equal to N upon N, right? So what will happen? Plus P naught minus P naught cancel out. So what left? PS upon P A naught minus PS is equal to N upon N, right? Clear? So again it will change that PA naught minus PS divided by PS is equal to N by N. Okay. So this is the equal to PA naught minus PS upon PA naught equal to N upon N plus N. So this is the what? Delta P. Okay, this is proportional of N upon N. Okay. So this is the final equation. So hence it is proved that relative lowering in vapor pressure depends upon the number of particles of the solute only. Okay. So this proves that this is also colligative properties. Okay. Let's do some numericals relating relative lowering in vapor pressures. Okay. Questions. The vapor pressure of benzene at 90 degrees Celsius is 1020 torr, right? 1020 torr, ठीक है? And so the vapor pressure of benzene at 90 degrees Celsius is 1020 torr. A solution of 5 gram of solute in 58.5 gram benzene has vapor pressure is 990 torr. Find molecular weight of the solute. So how will do? Let's do the solution. So according to formula of what you do, P naught minus PS upon P naught is equal to what? Doubly into divided by into. Okay. So that means what? Weight of the solute into molecular divided by molar mass of the solute into weight of the solvent. Okay. So what is the given weight? 5 gram into what is the molecular of benzene? Okay. Okay. So 5, what is the given? A solution of 5 gram. Okay. Solution is given 5 gram, right? So 5 into what is the molecular weight of benzene? C6H6 यानी कि 12 into 6 plus 6 72 plus 6 78 upon. So this is asking us in question, and so weight, what is the given? What is the given weight? 58.5. Again we have to put the P0 value. Okay, partial pressure of the, okay, right? now it is given 1020 minus 990 divided 990 is equal to 5 into 78 upon m into 58.5. So if you calculate, what we get? After calculating, we get 220 gram. This is the solution, right? Okay, right? So this is all about the relative lowering in vapor pressure. So move to next. What is the next colligative property? Second one is elevation in boiling point, right? So second is elevation in boiling point. Elevation in boiling point. Okay. So what is elevation in boiling point? So before that, we have to clear about the boiling points. Okay. So boiling point of a liquid is that the temperature at which the vapor pressure becomes equal to the atmospheric pressure. Okay. And now, if you talk about when a non-volatile solute dissolve in a volatile liquid, then the vapor pressure of that liquid will be decreases and boiling point will be increases. Why? Because of less number of particles of the solvent present in the solution at the surface as compared to the pure solvent. Clear? And suppose, and the what we tell, when non-volatile solute dissolve in a pure solvent, then the vapor pressure will be decreases and boiling point will be increases. Then the difference in boiling points of solution and pure solvent is called what? Elevation in boiling point. Okay. Suppose let TB is the boiling point of what? Solution, and TB node is boiling point of what? Pure solvent. Okay. Then delta TB. Okay. Or what happen? TB greater than TB node always. Okay. Solution has more. Clear? And difference in boiling point is delta TB is equal to TB minus TB node, right? This is delta TB is the what? Elevation in boiling point. Okay. And we know that the elevation in boiling point delta TB, okay, is directly proportional to what? Is directly proportional to lowering of vapor pressure of the solution, right? Then delta TB directly proportional to delta P. Delta P is what? Which is the P node minus PS. Okay, this is the lowering of vapor pressure in the solution, right? Or this is the what? NB upon N. Okay, NB upon N. Okay, number of moles. Okay, clear? Okay. So related this, we have to plot a graph. Okay. So graph will explain the boiling point of the solution in the solvent, right? So this is the vapor pressure, this is temperature in K, okay, and this is vapor pressure P naught PS, okay. So this is solvent, this is for solution, okay, and this point is what? TB, this point is TB node, this is TB. That means boiling point of the solution, this point boiling point of the solvent, this temperature, okay, this is the vapor pressure, okay. Now for detail, the elevation of boiling point, okay, elevation of boiling point directly proportional to what? Lowering of vapor pressure. Lowering of vapor pressure means what? P naught minus PS from this graph only, okay, because you check the curve, okay, P naught minus PS, it is decreasing, right? So what happened? From the graph, delta TB directly proportional to P naught minus PS from this graph, right? Now delta TB NB by NA, right? And this is equal to what? This is equal to what? WB into MA divided by molar mass of the into weight, right? So for solvent, we know for solvent, in this case what happened? P naught and MA is constant. MA is constant. So now what happened? Now delta TB is equal to, so if you remove proportionally, whatever constant will come. So K into WB divided by MA into WA, okay. So in this case, what is K? K is called what? Elevation constant. Elevation constant, okay. So if WB divided by MA is equal to 1 mole, suppose we take, right? So what will happen? Suppose this is equation 1, so 1 mole and WA is equal to 1 gram. So what will happen? Now delta TB is equal to what? K only, okay. Delta TB is equal to what? Only K, right? Again, so if we take and okay, so WB upon MA is equal to 1 and WA equal to what? 1000 gram. Now delta TB is equal to what? Is equal to what? Now if we put K, okay, now K is there. What is the formula? K into WB MA. This is MA into WA, okay. So K into what? This is 1 into, this is 1 right, divided by 1000. So K, this is equal to K upon 1000, which is equal to what? KB. Okay, so delta TB is equal to what? K into KB, right? Sorry, KB, right? So KB is what? KB here, KB is equal to what? Molar elevation constant. Molar elevation constant. Molar elevation constant or ebullioscopy constant, right? Molar, why it is molar? Because it is equal to, you just note that, so WB divided by MA. So what is this? What is this? Mass of the solute. This is molecular weight of the solute and weight of the solvent into 1000. Okay, so this is 1000 divided by K, right? So this is the formula of molality. Okay, so therefore it is called what? Molar elevation constant, KB. Okay, which value is what? K upon 1000. Okay, or we can written as, or delta TB is equal to what? Molality into K into B, or delta TB directly proportional to what? Molality. Finish. So this is the formula. Okay, so elevation in boiling point represented delta TB, which is formula molality into KB. Okay, or directly proportional to what? Molality. Okay, if you remove proportionality, what you get? Into KB. KB is what? Molar elevation constant, right? So this is all about elevation in boiling. So let's do one numerical questions. Okay, because with your numerical there is no enjoyable the concepts, right? So question 0.15 gram substance dissolved in 15 gram solvent okay, at a temperature higher by 0.216 degree Celsius, 0.21 degree Celsius, then that of pure solvent. Calculate molecular mass. Calculate molecular mass okay, calculate or molar mass. Okay, calculate molar mass of the substance. Okay, given Kb is equal to 2.16 degree Celsius mean inverse. Okay, so answer, you must try, pause here and you try for yourself. After that you can check the solution and match with. Okay, so what is the given first? We know that delta TB. Okay, put the formula. Delta TB is equal to what? Delta TB is equal to WB into MA divided by M into WA into KB, right? So this is the mass of the solute. So what is the mass of the solute? Which is mass of the solute? This amount of substance dissolved in 15 gram solvent. This is the solvent. So W, okay, so this is the WA, okay, and zero point 15 gram. What is 0.15 gram? This, okay, mass of the solute, because this is dissolve, okay, so this is WB, okay, dissolving 15 gram solvent at a temperature higher by 0.216 degrees Celsius than that of the pure solvent, okay. Calculate molar mass of the substance. So asking this, right? That means here given, sorry, this is constant, oh? We have to not applying this, okay, for the, because you already talked that for solvent P naught and Ma is constant, right? So now, so this is Kb. So what is the value of delta Tb? This is the delta Tb, elevation in boiling point, implies 0.216 is equal to what? 0.15 into, what is the value of Kb? 2.16, 2.16 whole divided by molar mass or molecular weight of 15 gram, 15 gram into what? Sorry, this is asking, right? M. So this is the 15, right? Now calculate, implies, so if you change M in this side, so what M is equal to, it will be come this side 0.15 into 2.16 whole divided by 0.216 into 15. So this is what? Now if you remove decimal, what happen? 15 upon 100, okay, into 216 upon 100 whole divided by 216 100 into 15. Now what happened? So it will be come to upper side, so 15 divided by 1000, okay, into 216 divided by 1000 into 1000 upon 216 into 15. Now 20 cancel out, 15 cancel out, 216 cancel out, sorry, so in this case what happened? So 0.15 into 216, okay, now 216 all divided by 1000 into 15. Now it will be coming out 15, 0.15 into, okay, now 15, so it will be close to that side. So what will happen? Into 1000 divided by 216, 10 cancel out, so it will be 15 divided by 100 only, okay. So what is the wrong? 0.15 15 ग्राम, ठीक है, okay. coming out 0.15 into 2.6 will divided by 15 into 0.216. बेसिकली it will decimal हटा दीजिए 15 divided by 100 216 divided by 100. now ये जो है कैंसल, ये तो 18 कैंसल, okay this so it is coming out कितना आ रहा है okay got it sorry so in this case you have to put what 1000 right because we have to change the modality okay in gram ठीक है so 0.15 into 2.16 into 1000 ठीक है in this case also 1000 so now it will coming out what 15 okay divided by 100 into 216 1000 into 1000 you cancel whole divided by this is 100 2020 cancelled out now 216 divided by 1000 into 15 now what happened 15 into 216 into 1000 divided by 216 into 15 so 216 cancel out 15 cancel out 0 okay so it will coming out 100 ठीक है so final answer is 100 gram okay so this is all about the colligative properties you practice and some of question I will give in the description as assignment questions so practice and whatever may be you can ask in my comment box okay thank you god bless you